IP policy routing illustration 77, information for IP policy routing. Routing can be simply described as looking at the content of IP header and checking the routing table to see where the packet should go. IP traffic usually should be forwarded according to the main routing table. On the base platform we have two other extra routing tables named Moon and Star. IP policy routing stands for the action by selecting a specific type of network traffic and forwarding them according to those extra routing tables. Those processes can be done by the setting at border reshuffle confined routing. There are three tables shown on the right. The first one on top of the right hand is to display traffic to / from a specific subnet should be handled according to routing table main, Moon, or Star. The second and third tables on the right are the content of the routing tables Moon and Star. The content of the main routing table can be found at System Network Static Routing. The following example is demonstrate how to use the functions here. We use IP policy routing to configure the base platform as follows. There are two bridges BR0 and BR4 in zone net. BR0 is connecting to the internet whereas BR4 is connecting to the subnet 10.0.0.0/8 that belongs to an ISP, Internet Service Provider. And BR5 is connecting to a subnet 172.16.14.0/24 with IP address 172.16.14.253. In order to use the subnet 10.0.0.0/8, the ISP asks for using IP address 10.1.1.23 with default gateway 10.1.1.1 and netmask 255.0.0.0. We would like to place some equipments on the subnet 172.16.14.0/24 so that those equipments will be connecting to a server in ISP's private network 10.0.0.0/8. However, 172.16.14.0/24 is our own subnet so that ISP will not route the traffic with source IP addresses from 172.16.14.0/24. Thus, traffic from the subnet 172.16.14.0/24 to 10.0.0.0/8 will be performed NAT by using the IP address of BR4 while passing the boundary of the bridge BR4. Illustration 78, example of two WAN ports. We ask one question here, why we would like to put BR4 into zone net. The reason is, although it is a private subnet of ISP, there are some other customers on it. Thus, we would like to block the traffic from this subnet by default. The other part of the system should function as usual, and the subnets of BR4 and BR5 should be isolated from the rest of the system. We proceed with the following setting below. Illustration 79, change bridges IP address. At first, the IP address of BR4 should be changed according to the assignment from ISP. It can be done via System Network Ethernet/DHCP. It should be in effect after rebooting the system. And this BR4 should belong to zone net. We change its zone definition at border reshuffle zone setting by removing it from zone LOC and adding it to net. To avoid it going back to default setting after reboot, please uncheck the box on top. The following screen snapshots to indicate removal of BR4 from LOC. Illustration 80, remove BR4 from zone LOC. Illustration 81, listing after removing BR4 from zone LOC. The following screen snapshots are for adding BR4 to zone net. Illustration 82, add BR4 to zone net. Illustration 83, list for BR4 in zone net. Then we change the setting to let the traffic from the subnet of BR4 to the subnet of BR4 be under NAT. In other words, the source IP address will be replaced by using the IP address of BR4. This can be done at border reshuffle port association. At first, remove the original setting of BR4 and BR5. Illustration 84, remove original subnet of BR4 for using NAT under BR0. Illustration 85, remove subnet of BR4 using NAT under BR0. Illustration 86, add subnet of BR5 using NAT under BR4. Illustration 87, list for subnet of BR5 using NAT under BR5. After we adjust the IP address of BR4, the zones of BR4 and BR5, and the relationship between BR5 and BR4, for NAT, we focus on setting the policies for routing. As mentioned earlier, the first box on the right is to display the corresponding routing table to use for specific type of traffic. And it is performed from top to bottom for every network packet passing through the base platform. If one rule is not matched, it goes to the next rule to check. Thus, the bottom two lines are using main routing table and default. Illustration 88, catch traffic destined to the subnet 10.0.0.0/8. The idea is simple, we would like to catch to / from the subnets of BR4 and BR5, and use the Moon routing table to determine where those network packets should go. The following screen snapshot indicates that we would like to catch the traffic from the subnet 10.0.0.0/8 and force them to look up the routing table Moon. Illustration 89, catch the traffic from the subnet 10.0.0.0/8. Please remember that 10.0.0.0/8 is the subnet that BR4 connects to. There are chances that some other subnets are sitting behind the subnet and they can be reached via the gateway provided by the ISP. Whether or not we should catch those packets to those subnets as well. A better approach is that we focus on catching the source subnets instead of listing all the destination subnets. There might be numerous subnets that all the packets are destined, but the number of source subnets are quite limited. Therefore, for those subnets for the field to in the configuration screen, we only specify adjacent subnets. For those remote subnets, we let the default gateway in the routing table to handle them. Illustration 90, catch the traffic from 172.16.14.0/24. Illustration 91, catch the traffic destined to 172.16.14.0/24 and please remember 172.16.14.0/24 is the subnet that BR5 connects to. Illustration 92, list rules for lookup routing tables. The box above shows traffic to / from the subnet 172.16.14.0/24 and 10.0.0.0/8 should look up the routing table moon, the rest of them should check the main routing table. The rest of the work is to create routing entries in the moon routing table. Image the situation that a host only with the interfaces of BR4 and BR5. We would like to create the content of the routing table similar to that case. Usually the routing entries for the subnets that the Ethernet interfaces are directly connected to are created at the time while setting the IP addresses of those Ethernet interfaces in the main routing table. But these steps will not be done automatically in the other routing tables. We have to add them manually. Other than the subnets associated with Ethernet interfaces, a default gateway is needed. If there is no routing entry matched the destination of a network packet, the packet is sent to the default gateway. There might be some chances to add some gateways to the other local subnets. These are roughly all the scenarios for the entries in the routing table. We add default gateway to the moon routing table as follows. Illustration 93, add default gateway in the moon routing table. After pressing add button, the corresponding routing entry will be displayed on the right under moon routing table. If nothing is shown after adding default gateway, it means the intended setting cannot be correct. The possible reason is, the IP address of BR4 is not in effect, so that you need to go back to check IP address is set properly and reboot the system to put it in effect. It is an obvious mistake that the gateway and the IP address of the interface are not in the same subnet. Illustration 94, default gateway in the moon routing table. The default gateway should be displayed as in the diagram above. To add the routing entries for those directly connected subnets, the process is very similar to setting the IP address and net mask for an Ethernet interface. The following screen snapshot is for adding the routing entry for the subnet that BR4 is directly connected. Illustration 95, add routing entry for the subnet connecting to BR4 in moon. Illustration 96, add routing entry for the subnet connecting to BR5 in moon. The screen snapshot above is for adding the routing entry for the subnet that BR5 is connecting to. The final result of the content of moon routing table is as follows. Illustration 97, content of moon routing table. There exists another routing table named star. If you have another pair of bridges for similar use, the routing entries for those specific traffic can be placed into that routing table. IP policy routing also can be used to set up some rules to send traffic to another machine for some other purposes. The steps are not as complicated as we introduce here. However, the network routing here is only limited to static routing. Dynamic routing only happens in main routing table. Those dynamic routing topics will be introduced later. HTTP reverse proxy for request filtering. In the previous sections, we cover the topics for port forwarding and IP load balance. The two approaches can forward HTTP requests, TCP port 80, to a server in the private network. Illustration 98, screen snapshot for HTTP reverse proxy. However, port forwarding and IP load balance are handling the requests based on the content of IP header. If there are two host names www.gaga.z and www.dada.z pointing to the same IP address, it cannot tell the difference from HTTP requests with the two host names by looking at IP header. The reverse proxy approach allows you to send the requests to different internal servers according to the host names in URLs. Illustration 99, HTTP reverse proxy for two different host names. Illustration 100, HTTP reverse proxy for two hosts.